Our world may have become dependent on fossil fuels, but man has the ability to change and evolve, and to prove that an alternative to dark, gloomy skies is possible. Several years ago, confronted with the planet's enormous energy challenges, a number of men came together around a crazy dream: the possibility of flying thanks to solar energy, and of proving that real progress is possible through the use of clean energy. This adventure has required years of studies and research by leading aeronautical engineers, supported by a solid team built around 2 men. Together, they have worked flat out to design and build a solar aircraft prototype capable of unprecedented feats. From the first draft plans to real-life tests on the runway, they had to continue to believe day after day that such an adventure was possible, despite the numerous obstacles, that an aircraft the size of an Airbus could really fly using nothing more than sunlight. Proving that new technology can enable us to reduce our dangerous dependence on oil. But if this message is to reach out across borders and frontiers and travel across the world, the plane will have to be able to fly by night as well as by day. It's 4:12 a.m. this July morning as shadowy figures tow the 64-meter-long aircraft call sign HB-SIA from its hangar at Payerne military air base in the center of Switzerland. The sun rises in an hour and a quarter, the time it will take the team to prepare the plane for its first full-scale mission. Flying non-stop for 24 hours, attempting to journey through the night, fueled by solar energy. More than 70 people have been working for years in the hope of seeing this flight become a reality. They know that the world is watching, but they're all here today because they have all believed in the idea launched by one remarkable man, Bertrand Piccard, a man from a family of scientists and explorers, recognized for discoveries that brought progress to their world and their age.
As far as I can remember, I have always been fascinated by exploration and scientific adventure.
Bertrand is the grandson of Auguste Piccard, who invented the pressurized cabin and who was the first man to enter the stratosphere in 1931. 30 years later, his son Jacques Piccard descended 11,000 meters below sea level to the deepest part of the ocean, the Mariana Trench, on board a bathyscaphe.
In my family, technology has always been used to understand nature and to protect the environment. So when I grew up, it became clear for me that I also wanted to perpetuate what I had admired.
Trained as a psychiatrist, Bertrand was soon inspired by the family's pioneer spirit. Initially a hang glider champion, Bertrand surprised the whole world when he made the first flight around the globe in a balloon with his co-pilot Brian Jones. The year was 1999.
After landing with the Orbiter 3, it was obvious that burning 3.7 tons of liquid propane, that was an adventure of the last century. And that's when I made a promise to myself that the next time I would fly around the world, it would be with no fuel at all, independent from fossil energy. And I think this is really a way to combine everything that fascinates me in life. Combining exploration, scientific adventure, and protection of the environment.
Bertrand's gaze then turned towards the sun, and the idea of using this power source to fly around the world suddenly seemed self-evident.
End of 2002, I presented this project to the Swiss Federal Institute of Technology. They were enthusiastic about it, and we decided to run a feasibility study whose lead would be given to André Borschberg.
I had asked to think about it for 24 hours, but I already had taken my decision. I found this idea unbelievably attractive.
When I met André, I met an entrepreneur, I met a very experienced pilot, And of course, immediately together, we started to develop a lot of synergies.
André is eminently equal to the project's scope and ambition. He knows and loves flying, and has even flown fighter planes for the Swiss Army. His corporate experience qualifies him to lead the future team of engineers. Peter Fry would be one of the first to be contacted.
Yeah, at the beginning I was a bit sort of watching what's going on, but I thought the idea to try to fly with solar energy is very exciting.
Peter Fry defines the configuration of the future solar aircraft, despite the almost complete absence of a frame of reference. Other solar prototypes have flown, notably an unmanned NASA craft, and one during the 80s, which only operated by day, but nothing so ambitious has been attempted before. Like Marcus Bazin, chief engineer, many team members signed up not really knowing what they were in for.
I mean, we are engineers. We're not doing miracles. If you look on the map of available airplanes in this world, something like this just doesn't exist.
When we try something that nobody has ever done, when we are in front of a blank page and we have to invent everything from scratch, it's obvious that we are facing the risk of failing. But I deeply believe that the worst thing in life is not to fail, it's to never try.
5:18 a.m. The aircraft is positioned at the end of the runway. Bertrand gives André 2 injections to ease his blood circulation over the next 24 hours, strapped into a constricted, unpressurized cockpit. His flight suit is inflatable and is designed to resist the most extreme temperatures. On each bicep, an electronic armband transmits the plane's horizontal position to the ground and sends vibrations to alert the pilot if necessary. A sensor on one finger enables the doctor on the ground to monitor the level of oxygen in the blood. From the life jacket to the parachute, every piece of the pilot's equipment has been designed to be as light as possible. At 5:30, the whole team have returned to their posts. The flight nerve center is called the mission room. In this tension-filled 150-square-foot room, the positional data, structural resistance, and the state of the electric motors are monitored minute by minute, as is the weather, a key element in the flight's success. If the team believes this 24-hour mission is really possible today, it is largely thanks to the extensive tests carried out in recent months. The freezing mist had slowly dissipated that December morning, allowing a cold sun to light up the main runway at Dubendorf Aerodrome.
André for Claude, can you hear me?
In charge of these first tests is a renowned former Swiss astronaut, Claude Nicolier.
We never took big jumps in the test. We went very progressively in speed. We slowly increased. We wanted to be sure that it was handling properly in the low speed before we were going to somewhat high speed, and we went always 5 knots by 5 knots.
At this point in the project, nobody yet knows if this albatross-like plane is able to fly, and above all, if it can be handled and controlled. An experienced test pilot has been designated to carry out the tests. His name is Marcus Schödel. For 10 years, he has exercised the rare profession of testing aircraft.
I thank you for helping to make it happen. Great, good luck.
Thank you.
Good luck. It's a great moment.
Thank you.
It's a risky job, and one of the things you learn is to manage risks. You have to be an engineer at one level, and the other thing is you have to be a pilot as well, so you're the link between the engineering and the flying. It's a very extreme project from a technological point of view, which is also challenging.
We have taken a lot of measures to reduce the risk. We built a cage around the cockpit to protect the pilot in case of any accident. But there is always the risk that the airplane goes out of the runway, lands in the grass, and could be strongly damaged, which could lead to delays of up to many months or maybe even a year there.
four 10-horsepower motors propel the plane at 5 knots, 15 knots, 20 knots. Then suddenly, at 24 knots, less than 50 kilometers an hour, the landing gear lifts off the runway and the aircraft travels more than 200 meters above the ground. Everyone is reassured by the plane's performance, and despite a dangerous instability controlled by Marcus, it's a major first victory for the Solar Impulse team. The machine can fly, and although they all know there is a long road ahead for it to fly further and higher, the emotion inspired by these brief moments in the air provides satisfaction and encouragement for the future. More than 100 years ago, in 1903, the Wright brothers Orville and Wilbur managed 100 meters in the air, and nobody at the time believed in the future of flying machines.
Solar Impulse recalls the past, the beginning of aviation with the first flea hops of the Wright brothers. But it's also an adventure of today. It's a new flight domain, it's new technologies allowing an airplane bigger and lighter than any other in the past to fly with absolutely no fuel. And this is the core of the project. Because very often when people think about renewable energies, about energy savings, they believe it's a threat for the lifestyle, for the mobility, for the growth of our economy. And we would like to demonstrate the opposite.
It's 6:32 a.m. and André has joined the plane on the runway. There is almost no wind. The atmosphere is one of anxious excitement.
Fix the emergency oxygen.
Raymond, see you later. Tomorrow morning. It's weird saying that, isn't it?
In the mission room, Raymond gives the signal for all the aircraft's parameters to be checked. The batteries were partially charged up by solar energy the day before.
Okay, in Alpha, then I'd like you to trim the pitch for 30 knots.
The 4 electric motors are activated and checked, one by one. In a few minutes, André will receive the go-ahead for takeoff.
Done. You fixed the boring.
The camera you have switched that you see now is filming.
Okay. Can you confirm that the air brakes are closed and locked?
Air brakes fully retracted and locked.
It's a big moment.
It's incredible.
My thoughts will be with you.
André
has extraordinary experience as a pilot, and so it's much more logical that he carries out this night flight mission, because it's absolutely vital that we make it, that we succeed, in order to give credibility to everything we're doing. And I'll continue to focus on the message that's so much a part of Solar Impulse, because for me, that's something that is fundamental. Have a good flight.
See you in 24 hours.
Yes, as late as possible, as late as possible.
Okay.
Gobi! Thanks a lot. Huh? Thanks a lot because you made it. Thanks a lot. See you 24 hours. Huh? Ciao. Huh?
Have a good flight. Enjoy it.
Will do.
India Alpha, we will be ready for departure 05.
Okay, André, the whole team is ready. You are clear to proceed, André. Have a good flight. We'll be with you during the whole flight. Have a good one.
Merci.
Thank you.
At exactly 6:52, the aircraft takes to the air like a dancer. In a deafening silence.
Bon vol, André.
C'est un moment extraordinaire.
It's the credibility of the whole project that's at stake over the next 24, 25 hours.
So this 24 hours flight will happen without the possibility to sleep and to rest. The airplane has no autopilot, so it needs to be controlled each time by the pilot, specifically when we have turbulences. And that's, I think, the first real main challenge. The second challenge, of course, is to fly through the night. Are we going to have enough energy to sustain the 6, 7, 8 hours that the night will last? Is the performance of the airplane sufficient? I'm sure the suspense will last until the end of the night.
The plane climbs gently on its giant wings and heads for the Alps, powered by a dazzling sun, reaching the altitude of the mountaintops. The day's objective is to accumulate vital solar energy in the batteries while reaching a maximum height before nightfall. Solar Impulse's trajectory is defined by the ground crew according to limits imposed by the Swiss authorities. For its first flight, the aircraft must remain over Swiss territory and not climb higher than 8,800 meters. At this height, according to weather expert Luc Tullmans, the mountain winds can be both an ally and an enemy.
I calculate the high altitude winds up to around 8,500 meters, and I check to see if the winds at that altitude, when he arrives there about 6 p.m. this evening, are not too strong. It was the only problem we had in making the forecasts, because we mustn't forget that at takeoff this morning, there were still winds of up to 90 kilometers an hour.
André continues to rise slowly at an average rate of 15 meters per minute, following a sinuous route between the Alps and the Jura. It is essential to find the right compromise between seeking the best exposure for the 12,000 solar cells and avoiding the worst headwinds, all the time continuing to gain altitude. The former fighter pilot has had to learn to fly with the elements in a plane barely the weight of a car, 1,600 kilos. The ultra-light weight is imposed by the current limitations of the solar cells and the batteries. a constant design puzzle for the engineers who, over the years, have tried and tested a variety of new aeronautical construction models. Every gram counts. The aircraft is constructed around a honeycomb skeleton of composite material surrounded by 2 layers of carbon fibers. A design conceived to integrate both weight constraints and the resistance factor. Each part of the skeleton was built in a shipyard and had to be baked in an oven to solidify the resin and consolidate the intermediary layers of carbon. The oven is 30 meters long and has to maintain a constant temperature of 70 degrees Celsius. When they are ready, each piece is subjected to a vital test, its resistance capacity. Weights are distributed along the fuselage to simulate the most extreme pressures the aircraft could experience in flight.
We pushed everything to the limits. And this was also in the last weeks a bit the feeling of external people that came to have a look at our project to give advice, that they felt uncomfortable because it's outside their knowledge, because we went so far to the limits. But we decided that we do step by step now, try to find out how our ideas work in reality.
The wing spinal column is called the longeron. It's the main element and the most fragile part of the structure. A total weight of 6 tons is distributed along the 60-meter-long structure, a nightmare for the engineers. If part of it were to break, almost 3 years' work on mathematical models would have to be re-evaluated, perhaps even the whole project. Two intense days of tests pass. The structure strains, but never breaks. The team knows there is little margin for error and that they have almost reached the limit. But the test results are conclusive.
This test was very critical during the specific phase of the development of the project. A failure would have meant that the technology we had chosen was the wrong one. But the success meant that we were within the weight budget available from the solar energy we could collect.
Around the spinal column, 120 carbon fiber ribs fan out every 50 centimeters, giving the wing its aerodynamic profile. The lower wing surface is covered with a light flexible film, and on the upper wing, the engineers place the solar cells. Once completed, the team can't resist giving the wing its first sunbathing session and dreaming for a moment of future flights. André takes advantage of the view, the altitude and the still bearable temperature, to eat and above all drink the required amount. Down below, in the mission room, the team continues to monitor the battery charge level.
In fact, in the center the batteries are full, the 2 central batteries are fully charged, so he's reducing the power of the solar panels to exactly the level of the motor.
Sébastien Daumont's team is responsible for the whole power and energy system.
At the moment, he's been generating more solar energy than the motors are consuming, for about an hour. So, we've been charging the batteries for about an hour, and we're now going to use part of that solar energy to climb higher, and the other part to recharge the batteries. The critical period where we really have to monitor the parameters is the high altitude period at the end of the day, with the objective of reaching an altitude of around 8,500 meters, with the batteries fully charged.
Look, that's the picture André sent from up there. That's so fun.
I took one while I still had a connection.
Right. I heard my phone ringing. I didn't imagine it would be you sending a photo from up there over the Jura.
Is everything okay at your end?
Everything's going extremely well here. It would appear that you have so much energy available that maybe you could send a little down to the ground. That would be even more effective.
Well, that's something else we can think about and maybe develop.
Yes, absolutely. So how are you feeling up there in terms of ergometry, the equipment, the piloting? Is everything fine?
Well, the handling of the plane is really superb. Excellent working conditions. And it's peaceful. I think that's really the word, it's peaceful. It's quite an extraordinary experience.
When he's at high altitude, it will be cold. The temperature will be around minus 20 degrees Celsius, and the batteries will be less efficient. The sun improves efficiency at lower levels when the batteries are hot, but we will lose a little efficiency at very high altitudes.
The altitude now obliges André to take in oxygen constantly, and the temperature has fallen to minus 10 degrees Celsius.
He's arriving at 23,000 feet, which is about 7,700 meters. So he has more or less another 1,000 to 1,500 meters to climb.
Weight constraints force the engineers to opt for an unpressurized cabin. The pilots have undergone specific training to test their resistance to the effects of altitude and the lack of oxygen. At an altitude of 4,000 meters, man can only exploit 70% of his capacities. At 8,500 meters, this falls to 20%. Training is therefore vital for maintaining effective reflexes in case of emergency. André, Bertrand and Marcus have also trained in survival techniques, perfecting their reactions in the case of forced evacuation. The restricted cockpit and numerous connections between man and machine demand well-rehearsed and precise movements and gestures.
In the Alpha solar telemetry, you have the go for the engine run-up of the inward engines, motor 2 and 3. Okay, I will dock motor 2 and 3.
7:40 p.m. The aircraft has reached maximum altitude, 8,720 meters. But everything has happened too fast. The plane has arrived 2 hours too soon, causing the team serious problems, as the winds at this height are still too strong. It's vital that the batteries are recharged to maximum levels before beginning the nighttime descent. The mission room is actively seeking the best trajectories to avoid wasting too much energy fighting the winds. Despite the team's efforts, the aircraft has to use more battery power than forecast.
There was one critical moment because we had planned to keep the aircraft exposed to the sun from behind for about an hour and a half. But the altitude wind was so strong that after half an hour, it had already passed from the Jura to the Alps, and so it had to turn back into the wind, facing the sun, so as not to drift too far from Payerne.
At this stage, no one is sure they can still take the risk of authorizing a night flight. The headwind means the plane is making almost no progress. The engineers have anticipated the possibility of strong gusts of wind. For this reason, the aircraft's aerodynamics and air resistance have to be thoroughly tested. The air resistance is tested at the aircraft's maximum speed, 90 kilometers an hour. Once it's assembled, the structure is subjected to a final mandatory test, the ground vibration test, carried out by the DLR, Germany's equivalent of NASA. This test involves setting every element of the construction in movement, checking that the vibration frequencies do not accelerate among themselves, and that the resulting resonance phenomenon will not cause the aircraft to break up during flight.
We measure the vibration of every element so we can really determine each frequency, be it the fuselage, the wing, the empennage, even the flaps, the ailerons, all the moving parts, which can each have an influence. Of course, if any moving part starts to vibrate, it can induce aerodynamic forces which can set the whole structure in motion. And if this resonates, it can last for up to 2 or 3 seconds. It doesn't last long, but just until the structure starts to break up.
André has descended to 7,500 meters, and the wind has dropped. He's patiently waiting for instructions from the ground. It's 10:15 p.m. and the batteries are 95% charged.
The decision has just been taken to spend the night in the air, so the suspense really starts now. André will get by on the altitude in the beginning, and then on the batteries, and the real night flight is officially beginning now.
Journalists from around the world and simple visitors alike share in the precious minutes that pass as night falls over Switzerland. A night unlike any other, when the light of day will still be active in the heart of the aircraft, if all goes well. Time seems to be suspended, as everyone holds their breath, as if prolonging the sun's last rays before venturing into the unknown. The first nocturnal solar flight. It is 11:22 p.m. and the sky is pitch black. The temperature in the cockpit is -8 degrees. The engineers had foreseen everything. But sometimes even the simplest thing can be overlooked. André's drinking water is frozen. He will have to manage without it. The aircraft adopts its nighttime speed, a slow descent to around 2,000 meters, using up as little energy as possible.
André for Bertrand. Can you tell us about your state of vigilance?
Well, for the moment it's fine. I'm not having too much difficulty. I was a little afraid I might get mixed up, not with the instruments, but just getting my eyes crossed. But for the moment I'm fine.
Okay, excellent. Bravo.
We'll see, it's still early.
To fly through the day is quite natural. You can see your position versus the horizon, but to fly through the night is much more difficult. That's not our natural environment, and it's not easy to have the right appreciation of the position of the airplane versus the horizon itself. And I think that's really the first difficulty.
– 2:45 a.m. André is aware that he cannot fall asleep, but allows himself some very short relaxation phases, brief visits to a part of the brain where the mind hovers on the edge of sleep, drifting in the dark waters of onerous memories, reflecting on the difficult decisions that had to be taken over 8 long years before reaching this point.
Because for the pilot, exactly, then you immediately feel if you have the control or
Zuerst kommen und sagen, warum wollen Sie das machen?
Herzureichen und dazu kommt unser Präsident.
If it's possible in the air, of course it's possible on the ground. We need desperately political courage. Reach the next sunrise before the batteries are empty. The message you have done today is a really great contribution. L'histoire en fait des parties différentes, mais s'unir dans une politique énergétique et environnementale ambitieuse.
I'm proud of you. I love you. Don't come back too soon, but do come back quickly.
I think I'll ask Yasmin not to ask you to come back too quickly. I think she can wait another 2 or 3 hours before she sees you.
4 a.m. It's the point of no return. All eyes in the mission room are glued to the fluctuating levels of the batteries, still supplying power to the 10 horsepower motors, despite the darkness. The electrical team devised a system for the motors to be powered alternatively by the solar generator or by the batteries. The engineers finally decided on 4 10-horsepower motors for security reasons. The resistance of the propellers and the motor's maximum power had to be tested in a wind tunnel up to their maximum power level. Powerful batteries were required to provide sufficient energy, although they are still, unfortunately, heavy. The batteries alone represent 25% of the aircraft's total weight. Hundreds of meters of cable connect the 12,000 photoelectric cells to the batteries. The cells are a compromise between weight and yield. Their efficiency could have been improved further, on a par with the solar panels used in space, but they would have been much too heavy. The cells too had to be tested, and their efficiency precisely calculated to evaluate the wingspan, finally extended to 64 meters. Solar cell technology is evolving rapidly, but has its limits and constraints. Overheating and short circuits have to be avoided, as they can occur in zones where shadows fall over part of the wing. It's a technology akin to lace making, where delicacy and precision are primordial, even for the pilot's every gesture.
We provide the pilot with instruments that give him his energy consumption levels, things like that. And he has to fly at very precise speeds. So extreme concentration is required to manage to conform to the parameters and to make the flight a success.
"4:45 a.m. Data levels in the mission room are positive. What the team feared the most, a nighttime forced landing, will be avoided.
Tu te rends compte?
Oui, c'est super.
C'est absolument dingue.
T'es content?
J'ai chialé tout à l'heure. Quand on a vu que ça marchait. André est encore super concentré, il m'a dit, il est encore dans l'avion. Nous, on commence à voir le succès de la mission arriver.
Ouais, c'est bien. Et il est en forme assez pour rester.
Ah ouais,
Il va rester encore quelques heures.
Non, super, c'est super bien. Tant purée, ça monte là.
We're beginning to believe more and more.
The breaking dawn lights up the prospect of achieving the first objective, reaching a new day. Up above, André can enjoy the spectacle of the world waking up. But down below, the tension mounts. The countdown before the liberation of sunrise has begun. This July night will have lasted 7 hours and 58 minutes. The batteries are just above 40% capacity.
Yeah, unbelievable, huh? We made it. Absolutely unbelievable. And now we can even make it with this 40%. That's super. Well, it was such a wonderful teamwork. I mean, I enjoy it. I tell you, I mean, being all together. Maybe not at the same place, but with the same spirit. Okay, so André, enjoy it. We see the sun coming up, and don't come too early. Huh? You have time to enjoy now, at least for 2 hours or 2.5 hours.
Absolutely, and we'll take advantage of it. We'll start recharging. We'll see it all coming alive. That's the whole point.
When you see the solar generator coming alive, that's also, I think, extraordinary moment and experience.
We look forward for the moment where you'll switch on the solar generator.
See you later.
See you later, André.
In just a few minutes, the aircraft will have flown around the clock, but it now has to prove it can load up on sunlight in order to confront the coming day. At 7:05 a.m., the solar generator is switched on. The batteries are once again being charged. 7:45 a.m. The engineers in the mission room contact Bertrand. A decision has to be taken. The more fastidious voices say that to reach the same battery level as at takeoff, proving a neutral cycle will require 4 more hours in the air. But André has been in the cockpit for more than 25 hours. And even if the aircraft is in perfect shape, they have to consider the pilot too.
Yes. The problem is we need decision. Okay, easy decision, then we come back. Yeah.
What we have done until now proves that the plane can catch the next rising sun of today, since yesterday, that it can carry on the flight, and that we can reload the battery. Now he's reloading. So basically, from now on, he could climb, and I think that's enough.
Okay. Easy decision.
We've got enough in there, look. Okay, André, we have a general agreement here, and we're unanimous. It's obvious that with the energy you're taking in now, you can climb to the same altitude as yesterday and do another night. So there's no need to prolong the flight. And according to the rest of the team, too, there's no need to do a second night flight to prove the neutral cycle, because what we've done so far already proves it.
Everything is clear like this also for you, André?
An excellent decision. I'm starting to roast in here.
So you'll be clear for landing in a little moment.
For the first time in the program, we've seen today the perpetual nature of flight. He could start again. The batteries are charged up to almost 45% now. He could set off for another day, spend the night in the air again, and then another day, and so on, perpetually. We could pretty much do it non-stop, and that is a really fantastic idea.
In 4 minutes, 5 minutes, André will be on the ground, and no one can say that what we've been saying until today is not possible.
Quite some distance after the touchdown point, André.
– 26 hours, 10 minutes. It's brilliant. It's a success, a complete success. Bravo, André, bravo. It was brilliant. We succeeded 1,000%.
I feel like I've lost my muscles.
It was great. Thank you, everybody. Thank you. It was great.
The aircraft has 12,000 solar cells built into its wings. It's designed to slowly ascend throughout the day, charging its batteries for the night flight.
Аппарат приземлился на аэродроме в Паюте и успешно завершились испытания самолета на солнечных батарейках.
Un avión propulsado exclusivamente por energía solar ha despegado con el objetivo de completar su primer viaje nocturno.
Objective for the next 3 years is to build a second airplane with much better performance. The first airplane is a test bench, the second one has to travel around the world. In the meantime, we learn how to fly a solar-powered airplane internationally and hopefully also over the Atlantic. New York-Le Bourget would be mythical if we could do the same flight as Lindbergh did in 1927, but this time with solar energy only.
The adventure of today is not to go back on the moon, but to make other impossible things happen, like getting rid of our dependency to oil, like solving environmental problems, but in a profitable way for the economy. Otherwise, nobody will ever follow that path. So you see that the adventure now is political, financial, scientific, that means very practical. But we absolutely need to keep the dream alive.
Before envisaging a round-the-world flight planned for 2014, the Solar Impulse team knows it must build an aircraft that is even more efficient and above all more comfortable for the pilots. But the very fact of having experienced this adventure for 26 hours straight and having shared and publicized the dream suddenly makes the prospect of an impossible future perfectly credible. Like the dream of a sun in the night sky.